Hello students, today we will discuss a new topic, conservative and non-conservative forces from the chapter Work, Energy and Power. What is meant by conservative force? A conservative force is one in which the work done by the force in moving a body is independent of the path traversed by the body, but it depends only on the initial and final positions. Example of a conservative force is gravitational force. How will we show that this does not depend on the path taken? For example, if you are taking a body from one point A to another point B through a height h, as we know the weight of the body, the mass of the body is m, then the weight of the body will be mg, and the work required for moving this height, that is equal to W is equal to mgh. Now let us imagine the same body we are taking through a slope of length L, inclined at an angle theta. This is h. So what will be the force acting on this, as well as what is the work done required, we will find out. Let us this be the mass, then the weight of the body will be acting vertically downward, which is mg. So you know it will have two components. One is horizontal component and the other is a vertical component. This angle is theta. So this is mg sine theta and this force is mg cos theta. So what will happen here? This force mg sine theta into the displacement is L. So how will we find out the work done there? Work done is equal to mg sine theta into L we get. It is minus because the force is acting in a negative direction. So we get minus mgl sine theta. Now we will see from this triangle what is L sine theta is equal to. This is theta, this is h, and this is L, hypotenuse. So what is sine theta here? Sine theta is equal to h by L. So h is nothing but L sine theta. So this is actually minus mg h. Here also the work done is minus mgh because the weight is acting downward and we are taking the body upward. So we got W is equal to mgh here, minus mgh here, as well as minus mgh here. So that means whether you take the body directly upward or through a slope, it is independent of the path taken. The work done is independent of the path taken. Both times you got the same value, minus mgh. That is the proof of that. Now another property of conservative force is total work done. Total work done by a conservative force on a particle is zero. Particle or a body is zero when it moves around any closed path. For example, a body we are taking from a point A to a point B through this path, let us imagine. You can call it as APB, and we are taking it back through another path called BQA. So in APB, let us imagine the displacement from the ground is h. So what we take is W is equal to, as we learned before, it is going upward, so it is minus mgh, and when it comes through, that is APB path, WAPB path, it is minus mgh. When it comes back through BQA, W is equal to minus plus mgh because it is going downward. So when we add these two work dones, the sum of this work done will be equal to 0. So that is the meaning of conservative force. The total work done by conservative force on a particle is 0 when it moves around any closed path. This is the closed path and returns to the initial position. Examples of conservative forces are gravitational force, electrostatic force, elastic forces like spring force. Now, a force is said to be non-conservative if work done by the force in moving a body is dependent on the path taken. It is different from the first one. It is dependent on the path taken. In non-conservative force, total work done by the force on a particle is not zero. Example is frictional force. So friction, what happens is, when the path increases. For example, a 1 meter path, if a body is traveling, a particular amount of friction will be the friction. As you know, it is a resistive force which acts opposite to the movement of the body. So 1 meter path, if the body is covering, if there is a certain amount of friction, then if the body is covering a 2 meter distance, the friction will increase to its double. Okay, so that is the reason why we say the frictional force is a non-conservative force. And frictional force work done will not be equal to 0. It is a non-zero value always. So a force is said to be non-conservative if work done by the force in moving a body is dependent on the path taken. Dependent means like this. If it travels a small distance, it will have less amount of frictional force, and if it travels a larger path, it will have more friction. Now, some other properties of conservative forces are as follows. Work done against these forces is conserved and gets stored in the body in the form of potential energy. Conservative forces, uh, when is acting on a body, their work done will be stored as potential energy. So potential energy we will study. Change in potential energy delta U is equal to minus work done by conservative force. That is the definition or concept of potential energy and work done. Work done against these forces is never dissipated by using or converted into non-usable forms of energy like heat or sound, light, etc. Work done against conservative force is a state function, not a path function. That means work done against some conservative force depends only on the initial and final positions of the body. It is independent of the path through which it is uh, that process was carried out. Work done against conservative force is 0 in a complete cycle.